Let's begin. Today is September 16th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 9, 12, 16, 19, and 22. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A looks at our first digit, triangle digit, and we'll compare that to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B looks at our 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C will compare our first and last digit, triangle and circle. So should the value of triangle be less than circle? Should they be equal to each other? Or should triangle be greater than circle? Criteria card D again looks at our 3-digit solution, but this time it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card E will look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F again looks at our 3-digit solution, but this time it'll let us know a little bit about its structure, specifically from triangle to square to circle. And basically, the 3 possibilities are the code may be in an ascending order, meaning that the digits are increasing, as in the example 135, or they could be in a descending order, meaning that they're decreasing and they go from 4 to 2 to 1, or potentially they may have no order, as in the example 231. Now notice in the example 231, it goes from 2 to 3, so it increases, and then it goes from 3 to 1 and decreases. It's that shift that's one way to describe that a 3-digit code has no order. We've seen in previous puzzles where if you have 2 consecutive equal digits, that also exhibits no order, since if you have consecutive digits next to each other, there's no change. So that is also another way to describe no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I want to test is I want to know a little bit about the ratio of even to odds. So let's go ahead and test criteria card D. Okay, so the Turing Machine does not approve of my proposal. Notice that I do have 2 odds to a single even. Since the Turing Machine does not approve of that, it's actually letting me know that there are indeed more even than odds. So let's go ahead and type that up in our notes in section D. So we have more even than odds. And of course there are 2 possibilities. It could be that at a minimum, yes, we do have 2 evens and an odd, or potentially it could be an all even solution. Okay, so let's see. Actually, I just thought of something. I don't think maybe it probably cannot be an all even solution, because if you consider the fact that, say, it's the same digit repeated 3 times, that has no order. If you have then 2 evens and an odd, well, let's see. No, I guess the 2 evens could be different. so that you'd have something like 2, 5, 4. Never mind. I think the only thing we can conclude is that perhaps they're not going to be the same even. Maybe that's what I was thinking. That if they're the same even, if they're consecutive, as I described earlier, that would be no order. And if they're the same, say 2, in the solution, say 2, 5, 2, then that also exhibits no order. So, I think I'm going to say that it's going to be, yeah, I'm going to say it's going to be a 2, a 4, and an odd, based on how I just described it. So yeah, I don't think you can have the same digit duplicated. So there's not going to be a pair. Yeah, because I think that would be no order. Very interesting. Okay, so I'll have to remember to reevaluate that conclusion at the end of the puzzle, but I'm going with that. They are going to be different. Okay. Well, that said, if they are different, a couple of things. We see that we also have criteria card B, which I have described in previous puzzles, where you can't have, well, obviously we can't have 3 3s because we know we have more evens. You can't even have 2 3s. But even if we didn't have this card, if we have criteria card B in the same puzzle as criteria card F, as I described the description of no order, there's no way that you could even have 2 3s for the same reason. Either they're going to be consecutive, which exhibit no order, or they're going to be triangle and circle, and square is going to be either less than or greater than, and that has no order. So we know that the 3 is either going to be there or not. And let's see, and we do have this triangle value where it could be equal, and so you'd have square and circle be the 2 evens. Let's see, we do have a little bit of all the digits, triangle, square, and circle, in some of these criteria cards. It would be interesting if, say, square were the odd, and we'd be comparing the 2 evens in triangle and circle. So let's see, so far I do have triangles less than circle. Let's go ahead and test criteria card C. Okay, so it is true that triangle is less than circle. So let's go ahead and type that up. And that is in section C. So triangle is less than circle. Now, again, that does not prove that we're talking about 2 evens. All we can say is that, yes, triangle must be smaller. So that means that triangle cannot be a 5, because if it were a 5, there's nothing bigger for circle to be. And then circle cannot be a 1, because if circle were 1, there's nothing triangle, anything smaller that triangle could be. Okay, let's see, what else? So I think I'm going to test criteria card E. Okay, so that is also true, that triangle, since I do have a 3 and a 1 for triangle and square, its sum is less than 6. The Turing machine confirms that. So yeah, it's true that triangle plus square must be less than 6. So let's go ahead and type that up, and that is in section E. Hold on. Oh yeah, that's right, yeah, E. Sorry about that. So triangle plus square is less than 6. Okay, so I think with that, I think we can actually cross out square the 5 square, because even if you add 5 to the smallest of 1, that's already 6 or greater. So that means it cannot be a 5. Okay, well, that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing our first digit to 3. We also didn't, and we know it, well, I guess no, yeah, we can have triangle B3. And criteria card B will let us know whether there's a 3 or not. And we didn't test that. And of course, we also have the no order. And I believe, now that I think about it, if you have criteria card B, if we know that triangle, we already know triangle is less than circle, but let's just do a for instance. If we knew that triangle, well, actually, I think it's the other way around. If you know the ordering is ascending, meaning it goes, say, from 1 to 4 to 5, then we would know that triangle is less than circle, making criteria card C irrelevant. So no, it can't be ascending. And if it was descending, then you know it would go, say, something like 4 to 3 to 2. And of course, in that case, triangle would be greater than circle, again making criteria card C irrelevant. So I think it's safe to assume that, or safe to deduce that the solution has no order. And again, it is because we do have this criteria card C and criteria card F that sort of interact with each other, and we're able to then deduce again that the solution has no order. Okay, so going back to criteria card E for a second, again, we do know we have 2 evens, and I've deduced, I probably should have written it as I deduced that there should be a 2 and a 4 based on criteria card F and the ordering, or you can't really have duplicate evens. It could be that triangle and square are evens, right? It could be 2, 4, 4, 2, where criteria card A would let us know which one, and then it could be that circle might be the 3, or since it's odd, it'll be the 5. So that's one possibility. Another possibility is that because we know the sum is less than 6 and we need an odd and an even, it could be that, you know, circle is one of the evens, maybe even triangle is the other even, and that's helping us sort of order the digits. Although, since I just said that, I don't think, if triangle were 4 and it's got to be less than, it would force square to be 1 and then circle to be 2. But then why would you need, let's see, what was I thinking? Why would you need, oh yeah, why would you need criteria card B? Because it almost defaults to not be a 3. So yeah, I think for that fact, I don't think it can be a 4. Because again, it forces it to be a 1, and then you'd have to choose a 2. There's no reason to have criteria card B. So yeah, I don't think it's going to be a 4. I'm not going to cross it out, but I don't think it's going to be a 4. And perhaps maybe even triangle is 3. It would force it to be, well, no, I guess, yeah, it would force it to be a 2 and then a 4. is that enough to say you really did need criteria card B either? Triangle is 3, forces it to be 2, and then 4. That's interesting as well. And so that would mean that, again, I don't think triangle could be a 1. Let's see. Could it be a 1? 1, 2, 4. It could be, but it does look like it's going to be less than. So I think what I'm going to do is, I'm thinking that triangle is going to be less than 3. And then it could either be 2, 4. No. Well, I guess it could be 2, 1, 4, where there is no 3. And because you did pick 2, it forces a square to be 1. But if it's a 2, yeah, I guess 2, it could be a 3. And then it forces a circle to be 4. Yeah, let's go with that. Let's try 2, 1, 4. Okay. So I've sort of deduced that it's going to be less than. What else can we test? I guess we can verify that there are no 3s. Yeah, let's go ahead and test criteria card B, the number of 3s. No, it's not correct. So there is a single 3 in our solution. Okay, so let's type that up. So the solution has a single 3-digit. Okay, well, that is very interesting. So if it defaults to circle, that would mean that the sum of the first 2 is 6. Well, no, we know it's not 6. So we know that 3 has to go somewhere in triangle or square. It cannot be circle. Again, based on our deductions. Okay, and then that means that circle cannot be 5. So that means, yeah, circle is even. So the question is, among triangle and square, which is going to be the odd? Well, the obvious may be that it could be triangle. So it could be 3, 2, 4. Yeah, because triangle has to be less than. So it's either going to be 3, 2, 4 or 1, 3, 2. Interesting. Okay. Yeah, let's go ahead. Yeah, oh, okay. So based on that, yeah, that means that triangle cannot be a 4, because since triangle has to be less than circle, yeah. So I think it's safe to cross out 4, and so we'll know whether it's less than 3 or equal to 3. So let's go ahead and test criteria card A. Okay, so that is true. So we know the 3 does not go in triangle, and well, we still don't know which is which. Oh, this is interesting. Okay, well, yeah, no, that means that square has to be the 3 based on, no, wait, no, we still have an odd. Oh, yeah, the fact that there is a 3 means that there can't be 1s either. I should have picked up on that much earlier. Yeah, the fact that there is a single 3 means that there can't be any other odds, and that means that square seems to have the only odd, so that means it can't be a 2 and it can't be a 4. And so based on that, oh, this is interesting. I have a descending solution. Well, I'm going to have to test it to verify. Oh man, this is going to be interesting. Okay. Nope, it's supposed to be descending. So where did I go wrong? I crossed out way too many things. Okay. So the last thing that I tested before the descending was that there had to be a 3-digit. So there is a 3. It is true that there should be no other odds. So no 5s and no 1s. That much is true. And I know that because criteria card D told us that there should be more evens, so there can only be 1 3, and criteria card B did not like the fact that it didn't have a 3. Okay? So based on criteria card C, where triangle has to be smaller than circle, that also means that triangle cannot be a 4. Okay. And then based on criteria card A, it did approve of my triangle being less than 3. So that means that it can't be a 3. Okay. So if triangle's 2, that means circle cannot be a 2, because 2 has to be smaller. So far so good. And it has to be descending. And of course, because, oh, well, the one thing, I guess the one thing that it may come back to bite me is maybe they are not distinct. I thought I made a good argument for them not being equal. So far I have not considered that, because I was about to cross out the 2 for square. If you have 2 equal even digits, well, okay, let's do this. Because we know criteria card E, the sum is less than, we know square cannot be a 4, because that'd be 2, 4. Okay. And yeah, I think square cannot be a 3. No, square can be a 3. I was about to say, well, yeah, no, I think, yeah, square cannot be a 3. Because if it were, circle cannot be a 3, there can only be 1 3. And if I choose square to be 3, it forces circle to be 4, hence a descending. And it's not descending. So, yeah, so somehow my argument was not valid. So it seems like it's 2, 2, 3. Well, that's very interesting. I'm going to cross this out because that seemed to have been a faulty deduction on my part. And I never did update my notes for A, which is that triangle needs to be less than 3. Okay, so, oh yeah, and of course that means that square cannot be, or sorry, circle cannot be 4. Okay, so let's see. So let's see. We confirmed A, that triangle needs to be less than 3. It is. We know the solution has a single 3 because it disapproved of the absence of 3. There it is. It's true that triangle is less than circle. We do have more even than odds. The sum of the first two is less than 6. And actually we did not deduce. We did confirm that the solution has no order, even though the deduction did come out to be true. I ended up confirming it. So that looks like the solution based on all of the, puzzle play here. Okay, I'll have to revisit that argument and see what went wrong. Okay, so I was wrong there. Glad we haven't proven, but yeah, let's go confirm that 223 is the solution. So 223. Great save. Glad I did not make that mistake. Of course, we're going to find out how we did versus a Turing machine. But anytime your number of questions equal the number of criteria cards, that's always at least a tie. So let's see. We did do C, D, E in the first round, and then we did the remaining 3 in the second round. And there was always a middle one that were incorrect. So let's type it C, D, E for the first round. So C was correct, D was incorrect, and E was correct. Second round, A was correct, B was incorrect, and F was correct. Okay, we still did beat the Turing machine by 1 question. I think, this puzzle could have gone the other direction and just gotten us the wrong answer. So something did not quite make sense. And so, I had to do a little backtracking and then use a little bit more logic. Like I said, if anyone can tell me why this argument was incorrect, what was my logical miscalculation, I would appreciate that in the comments. Or if you found any other inconsistencies or any other ideas, also add those to the comments. If you liked the video, please do give it a thumbs up. And of course, if you don't want to miss out on any future videos, please do hit subscribe to be notified. Well, until next time, have a great one.